Right, so before the break, right, we went over Riemann sum, right, sum of the rectangles. And then now just imagine, right, imagine if we make the rectangles goes to infinity, right, infinite number of rectangles. Instead of 6 rectangles, we have 6 million rectangle, right? Then the area of all the rectangle added up, it will be almost the same as the area under the curve, right? That was our original goal, right? Try to find the area under the curve. So that's what we're going to do, right? So far we completed step 1 and 2 by adding up the rectangles, right? But then now we are going to add in the limits, make the number of rectangle goes to infinity, okay? So as you can see, now if you look at this one, the very beginning question, now it kind of making sense now, right? This part is the sum of the rectangle. Adding the limit, it will make it into area of the under the curve, right? So what you get here, it actually represents area under the curve, all right? So let's take a look at an example here now. So here we want to approximate using infinite number of rectangles. All right, so you can see that the formula added in a limit, okay, n approaching infinity. And then the rest of them is the same, right? Sum of the rest of them here, this part is the Riemann sum, right? Delta x is saying that all the base are the same, right? It will be much easier, right? We pretend all the base are equal. So this example, we have a function parabola again, right? X squared plus 1. And we want to find the area under the curve of this parabola from -1 to 2 using equal interval, meaning the partition points, they are equally apart, okay? So first, let's set up the number line, okay? Look at the number line, where to see where the partition points are. So as we mentioned before, right, we need to find the base, how wide each base is, right? What was the formula, Joan?
Base, or the b minus a over n.
Yeah, very good. Okay, and our B is this, A is this first one, right? And then B is the last one. So B minus A. So Leon, can you find the base here, the delta X?
It'll be 3 over n.
Yeah, okay, so 2 minus -1 over n, right? Because there are n number of rectangle now. So it'll be 3 over n. So remember, n is constant right now, okay? Because we don't consider infinity yet. Later, we're adding infinity. Okay, so since the delta x is the base, 3 over n is the base. So if I want to get our x1, right, our second partition point, then I will need to add a base, right, to get a coordinate. Make sense, right? If the base is 0.6, then you add a 0.6, right? Now, if I want to add one more, right? If I want to get to the next one, I will need to add another base. So it'll be 3 over n times it by 2, right? And then so on. So each one of them will have a rectangle, right? This is a base, right? For first rectangle, second base for second rectangle, right? And then somewhere in the middle, right? In general, let's make it a bit wider, okay? They're all the same base, okay? I'm just making it wider so I can fit the writing in, right? So we would have the ith rectangle, okay? Let me draw the rectangle then, okay? So this is the rectangle I, right? And then this will, okay, let's not mess up the first one. Okay, so this will be xi, right? Rectangle 1, right? Rectangle 1 will be between x0 and x1, right? Rectangle 2 between x1 and x2. So rectangle I will be in between xi and xi minus 1. Any questions so far? Okay, so now let's get the value for the coordinates, right? So look at the first rectangle, okay? For the x1, the right-hand side, right, x1 will be -1 plus 3 over n, right? For the second rectangle, okay, let me draw a second rectangle there, R2, then the 3 over n needs to times it by 2, right? So for the right point, to get the xi, how do we find the value for that? Or not the value, the expression for that? Anyone?
Would it be -1 plus 3 over n times I?
Yeah, very good. So it'll be like this, right? And then for the left one, will be just changing it into, this one will be xi minus 1, right? Let me write bigger. Xi minus 1. How do we write the left side then?
Wait, -1 plus 3 over n times in brackets I minus 1.
Yes. Okay, so that's the only difference, right? So if the question says please use the right endpoint, right, which is what we are going to do, then use the xi. If it's the left endpoint, you use the xi minus 1. And if it's midpoint, okay, so this is for the right. Okay, later we'll make a conclusion, right? So if it's the midpoint, midpoint, okay, x. Then it will be, how do we write it? X, okay, midpoint is, you need to add them up, right? Find the average, right? So it will be x, how do we write it? Okay, we'll write x first, okay? X -1 plus 3 over n, and you take I plus I minus 1 over 2. So it'll be I plus I minus 1. Find the average of the two, divide by 2. Okay, so that will look like -1 plus 3 over n, 2i minus 1 over 2. So, okay, which will simplify into I minus 1/2. Any questions so far? Anyone got lost? Okay, so let's call this one xi minus half for midpoint. Okay, so these are three expressions for different ones. Okay, so this is for the left, this is for the right. Okay, right side, left side, midpoint. Okay, for this example, right? Of course, if they change the interval, then your base will be different, right? If they change the starting point instead of -1, then it will be different as well, right? So, but the pattern is here. Okay, so in this one, we are going to do the right endpoint. But first, let's draw the picture, okay? -1 to 2, 1, 2. Okay, and then vertex is at 1. -1 will be at 2. So it'll be here, here, here. 2 will be 5. Since we are not drawing the Riemann sum, right? We're not drawing approximating rectangle, so it doesn't really matter. We can just draw a more rough sketch, okay? So we want to find the area under the curve, okay? The actual area now, not the approximating. All right, so the setup will be finding the
Hey,
sum of
sir,
single. Yeah, Jesse.
how come the area under the curve doesn't extend into the negative?
Doesn't extend to the negative.
Or like into quadrant 3 and 4?
Because the height is starting from 0, right?
Oh, okay.
Yeah. Later we will have more than one graph. For example, you have another graph down there and you want to find the area in between, then there will be an extension to the bottom.
Okay, thank you.
Okay, so, and also because for each y value, right? When you get a y value is, for example, y value is 3, that means it starts from 0 to 3, right? So that's why the height is 3. Okay, so let's start with the definition, right? I'm just copying the thing on the top. I equal 1 to n, okay? F of zi. Zi is like the xi star, the partition point. This one, we are choosing it to be the right side, okay? So we'll write it as xi. If it's left side, then you do xi minus 1, okay? So, oops. I'll highlight that, right? xi minus 1, xi minus half, okay? And then delta x, because all the bases are the same. And then we take the limit, make it n approaching infinity, okay? So this one you should memorize, the the format, right? This is the definition for right partition point, right endpoint, for finding area under the curve. Okay, limit sigma I equal 1 to n. Now, because it's the right side, we figured that the xi will always be negative 1 plus 3i over n. Okay, delta x, we already found it to be 3 over n. Make sense so far? Okay, and then, yeah, questions?
Wait, I was gonna ask, do we are we able to pull out like the constant stuff?
The plug, what constant?
Like the 3 over n and stuff?
The 3 over, what do you mean plug?
Oh no, pull, like are we allowed to
Pull it
like pull it
yeah,
out?
later. Yes, yeah, later. We are
Oh,
going
okay.
to do that, right? So right now, first, let's plug in find the f of the negative 1 plus 3i over n. Okay, we're gonna plug it into the function, and then we are going to do what you did before the break. Okay, so our function is x squared plus 1. So it'll be negative 1 plus 3i over n. This is our input, square plus 1. Okay, and then
Wait, sorry, how do we get the squared?
function. Look at the function.
Oh, sorry.
Yeah. Okay, so this part is your input, right? Your xi. Okay, so you take that, sub it into the function so you can get the height, right? So this part is the height of the rectangle, right? Of every rectangle. This is the base of every rectangle. And then we sum it up, right? Sum them up, sigma. And then we take the limit, okay? So when you see this expression, this is what we've been trained for before the break, okay? So let's go back a couple pages back. Example 2. So this is what you've been preparing for, right? We learn how to do the pulling out constant, right? Get rid of brackets, share the sigma, blah, 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 right? And then split the n, right? Split into fractions, right? And then take the limit. Finally, at the end, you get the number out. Okay? So this is where we are right now. So we got here. So I'd like you to carry this out now. Okay, carefully. Okay, I'll let you try a couple minutes first, and then I will go over the steps. Okay, so the constant you need to pull out here What's the constant then? Nicole? What constant can you pull out?
Do we take 3 over n?
Yes, okay. 3 over n is the constant. Okay. Because the only thing that's changing is the I, right? You deal with the limit later. So right now, your job is to get everything in terms of I. Sorry, in terms of n first, okay? So once you get here, your next job is to simplify everything, get rid of all the brackets. So everything is add and subtract. And then you can begin splitting the sigma, okay? Make sure you simplify, okay? Combine any like terms possible. So you don't have too many sigma to deal with, right?
Wait, Jason, do we expand the -1 plus 3i over n squared?
Yeah, you get rid of all the brackets, combine
Okay.
all the like terms, and then you share in the sigmas.
Okay, thank you.
Yeah, you're welcome. Okay, when you expand, please expand carefully, okay? Don't rush. This is a plus b squared. It's a formula, okay? You gotta use the formula. Don't just square each one. I'm just going to add it with other one together, okay? So makes it 2. Okay, let me know if you have any questions here. And then you can start splitting the sigmas. Pull out a constant. Any questions? You need to ask me during class, okay? Otherwise, homework, you will have trouble, okay? And then each of the sigma will have a formula, okay? So you can flip back to the formula page, right? Formula page is here, right? You have 5 formulas. Pick the one that you need. Okay, what is sigma of 2? Joan, sigma of 2, what do you get?
2n.
Yeah, very good, 2n. Okay, and then sigma of I, Leon?
N multiplied by n plus 1 all divided by 2.
Yeah, very good. 9 over n squared. Sigma of I squared is the long one, right? So take a look at your formula sheet, formula page, or better is to remember it, okay? Now you can start to bring in the 3 over n. Okay, we have three terms, right? 3 terms here. Bring in the 3 over n and then try to reduce things, right? Reduce stuff. And then pair up the fraction, right? Split up the fraction like we did here in this exercise, right? We bring in the 4 over n, canceled out stuff, and then you pair each n on the top with the n at the bottom, okay? So if you are able to find the final answer, okay, please raise your hand. And remember it was a nice number, is it? Jesse, what number do you have?
I got 6.
6, right? Like nice number. Yeah,
Yeah.
it was an integer.
Yeah.
So what that means, this number is the area of the red, okay? The red shaded, the actual area. Okay, raise your hand if you either get stuck or got the answer of 6. I think 6 should be right. So remember when you were learning derivative, right? You had to do the definition way, right? H approaching 0, the limit, blah, 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 right? So this is what we are doing right now. We are doing it for the finding area. So next class, we'll be learning the faster way, right? With the formulas. So that you can get the answer, right? Without doing all this sigma and limit stuff. Okay, so let's multiply in. Okay, see if you simplified it right. So multiply the first one will give you 6. That will be 18. N will cancel out, right? So n plus 1 over n. 2n. Plus 27. N plus 1. 2n plus 1. Okay, raise your hand if you finished. And then denominator is 6n squared. Any mistake here? 27. And then we can start splitting up the fractions. That'll be 9 n plus 1 over n, 9 over 2, n plus 1 over n, 2n plus 1 over n. Anyone has question here of any step? Can check, okay? Check with the screen. Jeffy, did you get 6?
Yep, I got 6.
Okay, Emily, how about you?
I also got 6.
Yep, okay. Now if we take the limit, this will go to 1, this will be 1, this will be 2, right? So it will be 6 minus 9 plus 9 plus 9, right? Plus 9. Okay, then that will give you an answer of 6. Okay, raise your hand, okay, if you finished. And make sure you understand every step here, okay? So then when you look at the homework, right, you can always go back to review, okay? Lex, how are you doing? Any trouble?
I'm just reading it. Give me
Okay,
like another minute.
yep. Okay, so let's take a look, okay? So this is how we find area under the curve using limits, okay? Of course, this is a very tedious work. And left endpoints will be even more complicated, right? More stuff because the thing you are subbing into the function has an I minus 1, okay? So when you try to square, it's more work to that. So usually if the question doesn't specify, then you always choose the left endpoint. Okay, left endpoint, you just have the I, right? So let's make a summary of different points that you use. Okay, so that's if you have space, right, you can write it in here, or you find a other page, right, to write a summary. So let's put it here. Summary of all the different partition points. Okay, so if it's the right side, in general, okay, then your xi will be a, which is the -1 in this question, right? A plus b minus a over n, which is the base, times it by I, right? Delta xi. Okay, take a look. It's nothing new, right? Same as the one on the highlighted on the top, right? And then left, it will be xi minus 1. So same thing, everything the same, base, but then it will be I minus 1 in brackets. Okay? And then midpoint will be x I minus a half. It will equal to, right, not dot, okay, equal to a plus b minus a over n, I minus a half. Okay, and most of the time, right, if they don't tell you which one to use, always use the right side, okay? Much better, easier to calculate, okay? So after you finish copying, can you raise your hand again? All right, so let's do one more question, okay, before we end the class today. So writing out with this definition is pretty long, right? So limit, right, sigma, blah, right, a lot of writing. So they design a symbol to replace this part, right? And then they call that integral, right? Integral integrate. So which means adding up, right? Put everything together. So when you see limit, sigma, or you see the integral sign here, right? This one looks like the symbol you see on the violin, right? The empty hole on the violin, right? So it looks like an S being stretched, okay? So what that means is find the area under the curve, okay? With this example, we will explain a little bit more. It's not just the area, it's something else as well, okay? So if this thing exists, right, which is what we've been doing just now, right? This thing has a limit exists, get a number, right? We got a 6. Then we will say the function is integrable. Just like when we do the definition for derivative, right? If the limit for h approaching 0 exists, then we will say the function is differentiable, right? You're able to find the slope of tangent. Now for this one, if you get an answer out, then you will say it's integrable. You are able to find the area under the curve, okay? Try to reflect to what we learned before. And then on this interval here. So right now it's just changing the symbol. Everything else the same, okay? Same idea. So the delta x, the base is here, right? dx. See, it's connecting to our derivative chapter now, right? Is the small tiny base, right? Small difference of x. Remember dx is the small run of the dy over dx, the rise over run, right? So it's the small base. And then the f of x is like this part, f of zi, it will represent the height. Right? So base times height give you the rectangle, right? So everything on the right side is rectangles. And then integral sign means you're adding up all the rectangle and making it infinite, right? So the one symbol here includes two things. Adding the rectangle up and make it infinite, okay? So that way we don't have to write limit and sigma. And this is called the definite integral. It's called definite because we know exactly A to B, right? We know the boundary, where to where, okay? Later we'll learn about something called indefinite integral, okay, next time. And the meaning of what you get, okay, here is the word, right? Net area. It's not just the area, okay? It's called the net area. And I'll explain what net area means after we finish this example, okay? So net area between the function and the x-axis. All right, so let's just try to practice with this function, okay, this symbol. So by looking at this example here, we can tell two things. One is the function, right? What's the function here? Leon, what's the function for this question?
X squared minus 4 dx.
It's actually just x squared minus 4.
Oh.
Okay, the
Wait,
dx is the base. Yeah?
Wait, how come the dx is like attached to the 4 though?
Dx attached to the 4. Oh, it's not attached to the 4. So you can look at it like that.
Oh, okay.
They don't show the bracket. Usually they don't show it, okay? Because yeah, it's an invisible brackets, okay? So we'll assume that the everything between the dx and the integral sign is the function, okay? And the second thing that we can tell from here is what? What's the other thing we can tell from here?
Like the endpoints?
Yes, very good. So our interval is from -1 to 3. So remember, you got to read from bottom up. The bottom is the A, the top is the B. Okay, so from this symbol, we can tell these two things, and that's already enough for us to set up everything. Okay, so you can, so from here, I would like you to carry out the same thing here using the right endpoints. Okay, for the rest of the class. Okay, we'll be using the right side. So first thing you need to do is to find out what's the xi. Okay, and then you go to this step, the start. Okay, write out the start, and then after that you just sub into the function. All right, so I'll let you go for it, and then after a couple minutes I will check each step. Okay, first write out the xi. You can write it down here. Okay, what the xi equals.
Xi is like the first, like first like endpoint, right?
No, xi is this one, the right endpoint.
Oh, okay.
Yeah, you gotta use this formula. Okay.
Okay.
So the xi represents every single right endpoint in general. Okay, if you got the xi, can you raise your hand? Okay, Carrie, can you tell me your xi?
I got -1 plus 4i over n.
Okay, very good. Okay, if anyone has questions about how to get that, let me know. Okay, then I can explain. Once you get xi, you just sub it in, right? -1 plus 4i over n. And then your base is 4 over n, okay? And then do the same thing as before. Plug it into the function. Okay, at the end, you should get a number out, all right?
Is it a nice number?
I don't remember. I think it's a fraction.
Oh, okay.
Did you finish already?
No, I was just wondering.
Okay. And let's also draw it out too, okay? -1, 1, 2, 3. This one has a vertex of -4. 1, 2, 3, 4. -1 will be at -3. 2 will be 0. 3 will be 5. 1, 2, 3, 4, 5. Okay, so as you can see from the graph, parts of the area is underneath, part of the area is above, right? So you have rectangles down here, right? Also has rectangles above, right? Because all the y value are starting from x-axis. So you get some rectangle under, some rectangle above.
Wait, Jason, I got an integer.
Integer. Okay. What's your integer?
Wait, let me do math for a second.
Okay.
Got 26. No, not 26, 36.
36. Okay. Double check. Okay. I don't remember seeing this number before. Okay, let me pull out the notes from before, okay, and then tell you what that is.
Oh, wait. Sorry, I did something wrong.
Okay.
I have negative 20 over. Wait. I can't have a negative number.
You could. You could.
Oh, okay.
That's-
I got negative 20 over 3.
Okay, that's what I'm gonna talk about later. Okay. So negative. Say that again.
Negative 20 over 3.
Okay. So please raise your hand if you get a final answer. Okay, I'm gonna show next step, okay? So you guys can check along, right? So I'm gonna skip a few steps though, okay? So square that, so it'll be 1 minus 8i over n plus 16i squared over n squared minus 4. 4 over n, negative 3. Anyone else finished? Please raise your hand. Yeah, the answer should be negative 20 over 3, okay? Yeah, I just checked. So raise your hand if you get the same answer or not, okay? So now each one will be negative 3n minus a over n, n plus 1 over 2, 16 over n cubed. Simplify it, so that will be negative 12 minus 16 n plus 1 over n plus 32 over 3 n plus 1 over n. Any mistake here? Jeffy, do you have the same answers?
Yep, I got the same thing.
Okay, Leon?
Yeah, same.
Yep. Okay. So that goes to 1, that goes to 2, okay? That goes to 1. And then you just calculate everything, okay? And then you get an answer here, negative 20 over 3. So why do we get a negative number here? Anyone has any idea here?
Is it because the amount of shaded area under that's in quadrant 3 of 4 is more than like the one in quadrant 1?
Yeah. Okay. So you think about how we used to interpret area, right? When we do the Riemann sum, right? Because when we get area, the height depending on where the curve is, right? If the curve goes under, that means you kind of you are getting a negative height, right? So the rectangle that you get for the one underneath will have a negative value for the area. And then you add it with the area above, okay? So what you get is actually called the net area, not the real area. So this one is, let's call this part the A1. This part is the A2. So it will be A1, which is negative, right? Added with A2. Okay, so this is called the net area. So so if you want to find the actual area, you need to do it separately, right? For example, you find the area from negative 1 to 2, right? Find the bottom area, make it positive, right? You will get an answer that's negative, you make it positive. And then find A2 and then add them up. Then that will be the real area, okay? Otherwise, doing this way will always give you just the net area. And the reason why net area is important is later on when we do applications, okay? The area underneath could represent like the expense, right? And the above is like revenue, right? So at the end, you get the net profit, okay? So this is one of the application. And also like velocity, right? Velocity got to do with area of the, if you take physics, it will be the area with the under the curve of the displacement functions, okay, or yeah, what was that, position function, right? So sometimes you can turn around going to the left, and then turn around going to the right. So when you get the area, it's like finding the displacement instead of distance. So distance is like area, okay? And displacement is like the net area. All right, so later on when we have application, I will mention this again. Okay. Now, I think that's all we will cover today. Okay, so if you have questions, you can stay after class, and I'll see you next week. Okay.
Thank you.
Yeah.
Appreciate
Thank
Thank
you,
you,
Jason.
Okay, you're welcome.
Thank
Bye-bye.
you.
Good night.